In part B, we're being asked to solve a differential equation again. However, we're being asked to solve for a particular solution to this differential equation, and we're given an initial condition of 1, 0. And that allows us to solve for that plus c. So I'm still going to separate this out. So the y's with dy's, my x's with dx's. Okay, so separating this out, I'm going to separate this by times and divide. So dy over 1 minus y, that's going to be equal to dx over x. So I've separated my variables. I'm going to integrate both sides. So I get log 1 minus y. And then because of that negative y, I have to account for that negative by dividing by -1. So I'm just going to put that out there. This becomes log of x, and I need a plus c here. Okay, there's a few ways I can deal with that plus c. I can solve for it now the way it is. I think I want to get rid of that negative so that it doesn't distract me and I don't lose that negative. So I'm going to write this as c minus c, and we'll call that c2 because that's different than that c, minus log x. Okay, I could make that negative c, but it's no point having an extra negative when it's just a constant. And I can put this into an exponential function and deal with that c. So it looks like this. There's different ways I can do with this. So one way is to put it to exponent. So I get 1 minus y is equal to e to the c minus log x. Okay, and then I can deal with this as 1 minus y. And again, that c can end up being a multiplier. So we end up as e to the c, and then we end up with times e to the negative log x. Okay, and since log and e undo each other, I'm going to put that negative in here, and I end up with log 1 over x. Okay, and then I can simplify this. This ends up being 1 minus that constant e we can solve for. I'm just going to call that k. K e to the 1 log 1 over x. That simplifies, that's an identity. That's just going to become 1 over x. And that's going to be equal to the y on the other side. And then I can solve for that k by substituting in our initial condition. So plugging in my initial condition, I get 1 minus, I'm solving for k. I'm going to plug in x is 1, y is 0. So in this case, k is going to be equal to 1. Okay, so my final equation then is going to be 1 y equals y equals 1 minus 1 over x. Okay, so that's one way to deal with that k, or that plus c. An alternative, I'm just going to do it over here. An alternative would be we can solve for that plus c in this way here. We could just plug it in. And in fact, since that c is a multiplier, I'm going to do this. So I'm going to have negative log 1 minus y. Okay, so just so that you know where I'm pulling this from, I'm just going to pull it from here. 1 minus y equals log x plus log k. Okay, and then the reason why I do that is that log k and that plus c are really the same thing. So that plus c here, this plus c here, and this plus log k is the same. It's just some constant. This allows me to embed that constant into the logs. It allows me to use log rules to put that together. And I'm going to move that negative to the other side. This is going to be negative log of kx. Okay, and then solving for this, I'm going to want to drop the log, so I want to put that negative in there to start. So 1 minus y is equal to log of 1 over k. And then I can drop the logs. 1 minus y is equal to 1 over kx. And I'm going to put the k in the numerator so that it looks, well, we can solve for k here. I'm just going to solve for k. We end up solving for k equals 1. So when I plug in y equals 0 and x equals 1, again, we can see that k equals 1. So then plugging back into this equation here, I get 1 minus y equals 1 over x. And again, I get the same equation, y equals 1 minus x. Okay, so that's dealing with that plus c in a different way than I did in the first solution. Lastly, drawing in the slope field, we're going to just plug in x and y coordinates into the differential equation, and we're going to draw slope segments. So my equation is 1 minus y divided by x. So at y equals 1, I'm going to end up in the numerator 1 minus 1. So I'm going to get 0 slope here. I'm going to get 0 slope here. Okay, let's draw that a little bit nicer. 0 slope in here. I'm going to 0 slope in here. When x is equal to negative 2 and y is equal to 0, I get negative 1/2. So I'm going to get kind of a slope like that. When y is 0, x is negative 1, I'm going to get a steeper slope of negative 1. When x is 1, y is 0, I get positive 1. When x is 2, y is 0, I get positive 1/2, so it's going to be not quite as steep. Okay, and then for the last 2 points, when y is negative 1, I'm going to end up with the numerator equaling 2. The denominator is going to be negative 1, so I get negative 2 as my slope, so I get a little bit steeper slope through here. And then when y is negative 1, I get 2 in the numerator. X is positive 1, I get positive 2 slope, so it's going to be steeper through there. Okay, so that's the general, I'm just plugging in x and y coordinates to get a slope, and I'm estimating that slope and sketching in a little line segment.